Hello and welcome to this presentation of the Fronius backup solutions that are available with the Gen24 inverter and battery systems. So why may you need a backup solution for your PV system? There's a number of reasons for this. Primarily, customers in rural locations with a weak grid infrastructure are more prone to grid outages. Additionally, in recent times we've seen a number of significant storms, and these have in the short term caused grid interruptions, but also left some customers without power for a number of days or even weeks. And thirdly, there are those customers who just want to have that peace of mind to know that their system and their house is still going to be operational even if there is a future grid outage. So let's have a look at the basics of grid backup systems. Under normal operations, your grid-tied PV system will be able to generate energy from the rooftop, feed that into the inverter, and then distribute that energy to the loads within the property, and potentially export energy that's unrequired locally back to the grid, if there's no limit for that system. If there's a grid failure, one of the responsibilities of the inverter is to enable anti-islanding mode. This means that the PV system is no longer able to generate electricity and potentially feed that back to the grid where somebody may be working to re-establish the grid connection. This is an important safety feature of grid-tied inverters. So you'll see that there is no energy being produced by the PV, the inverter is switched off, and of course there is no power available within the property. All devices are now switched off. There's no lighting, no heating, the shower won't work, and of course you won't be able to charge your vehicle. There's no supply back to the grid either. In backup mode, we can install a device which stops energy being generated flowing back to the grid, protecting those workers that will be re-establishing the connection. However, it enables the inverter to stay active, drawing energy from the panels and also powering your supplies within the property. Potentially as well, you can charge your battery and ensure that you have energy being topped up into that battery for the evening when you may need it in darkness. It's important to consider the amount of power that's available from your PV system in backup mode. You're limited, of course, by the amount of sunlight, the maximum power output of the inverter, and also the charging and discharging capabilities of the battery. So what can we do to prolong the availability of the battery? Well, first of all, we can reduce the amount of load on site by switching off unneeded equipment such as an oven or maybe a power shower. Also, we can make sure that any EV chargers are either in fallback mode or on non-essential circuits within the building which are not backed up by the PV system. Then we're only powering those most important things, maybe the lighting, your fridge freezer, a boiler, to make sure that you're going to get the maximum life out of that battery before it can recharge. So we have a number of different solutions available for Fronius backup, and it's important to understand the different topologies for these. We can have devices which are connected directly at the inverter. This is called our PV point system. We could have a backup controller or switch which are installed just on essential loads within the property. Or we could look at a full household backup so that all loads are covered by the PV and backup system. So let's have a look at each one of those in turn. To start with, we have our PV point system. This is installed within the inverter itself. It's a dedicated AC outlet circuit and only becomes live when there is a grid failure. So if you connect any loads or circuits to this, they will only operate during a grid failure. We can have up to 13 amps, 3 kilowatts single phase loads connected to the circuit, and this is a very low cost solution that's on all Gen24 devices. Please note, for all of these solutions you do need to have a local earth rod on site. This is to provide your protective earth in case there is a disconnection from the grid earth outside the property. For added simplicity and ease of operation, Fronius now have the PV Point Comfort solution. This is a retrofittable circuit board which fits into the AC compartment of the Gen24. This enables the PV point circuit to remain live during a grid failure, but also in normal AC grid connection mode, meaning that you no longer have to switch devices off and reconnect them in the event of a grid failure. Retrofittable board can be purchased from Fronius distributors and installed easily within the inverter. Again, we need to have that local earth rod within the property and also a local RCD for those circuits connected to the PV point comfort device. My colleagues at Fronius International have put together a number of how-to videos that will help you understand the installation and commissioning process for the various different backup solutions. Let's look at the process for PV point.
With the PV point comfort, a continuous supply of your emergency power loads is possible. When the PG clamp is installed on the inverter space, we next up can install the AC cable coming from the emergency power device and install it to the PV point connection of the Gen24 Plus. To do that, we start with the protective earth cable, and we now need to make sure to get the protective earth signal from the PV point clamp to the PE clamp of the inverter. Second thing, we want to install the PE cable coming from the emergency power device directly on the PE clamp in the inverter. When we have installed the protective earth cable, next up we want to put in the isolation plastics to make sure that the PE connection is not connected to the PC board of the PV point. After that, you are now able to install the PC board of the PV point directly into the base of the inverter with the 4 screws that you get delivered with the package. Please make sure to secure the screws of the PV point comfort with 1 pound 2 Newton meters of torque. After we have installed the PC board, we can next up start to connect the cables to the inverter as well as to the PV point load. Next up, we do the connection between the PV point comfort card and the connection point to the inverter. As soon as you finish, you can now connect the PV point load directly to the PC board with the screws that you find down below here. There is a cable clamp and you can use that to install your electric socket, for example. Last but not least, we want to install the AC connection part from the electrical grid to install it to the inverter. And therefore we have one last clamp on the right bottom side of the PV point comfort, and therefore we want to install phase 1 and the neutral contactor to make sure that the PV point comfort is continuously supplied. Phase 2 and 3 can be directly connected to the inverter clamp. After we finish the installation of the AC side and the PV point side, we can then close the cover of the Gen24 Plus again. For the connection to the socket or to the single phase outlet that you want to install on the PV point comfort, please make sure that you need at least an RCD type A 30 milliamps as well as a circuit breaker with 13 amps to secure your electrical line. You can do that like we did, for example, with a combined device of an RCD and a circuit breaker in one with 13 amps of circuit breaker and 30 milliamps type A RCD. For the commissioning of the PV point comfort, last thing that we need to do now is to connect to the web interface of the Gen24 Plus and activate the PV point there. To activate the PV point comfort now and to do the commissioning, you can directly enter the settings on your inverter, or during first commission, during initial commissioning, you can enter the point function and IOs. Here you will find the point backup power, and you can open the setting and activate the backup power by clicking on this switch here. After that, you can switch the configuration mode and you can switch here PV point. And afterwards, please set the correct voltage depending on your region. Last but not least, you can determine an SOC warning level where you will get a notification before backup power mode will stop, as well as a reserved capacity. Whenever you are using stationary battery systems, you can use the reserved capacity to make sure that at least a reserved capacity is available for your backup power functionality.
The next option available is our Fronius backup switch, and this is positioned for essential loads. So this is mounted external to the inverter and enables certain loads which are essential on the site to remain connected when there is a grid failure. When the grid fails, simply switch between the grid connection mode and the backup mode manually. The backup switch is available as the 3P and 3PN variants. 3P means three-phase, but also works as a single-phase device, and the N means neutral switching. We recommend that UK and Ireland customers go for the 3PN device. It has a 63 amp switching load, which means that for residential installations where the incoming supply is 63 amps, this device can cover the whole house. However, if you have a 100 amp incoming supply, we'd recommend breaking out the non-essential loads, those high loads such as an oven, an EV charger, and then only backing up the essential devices that you need to operate during a grid failure. Of course, this needs a manual switching between the grid mode and the backup mode, but it is a very low cost and simple solution. Here's the commissioning video for the backup switch.
In this video, we are going to show you how to install and commission the Fronius backup switch. With the new Fronius backup switch, you have now very easily and compact the possibility to switch over a full household with three-phase power. On the one hand side, we have the grid parallel position, and on the other hand side, you can switch over to backup position manually. In this case, you are going over the zero position that make sure that the inverter is switched off and will power up again in the backup position. On the top side here, you see coming from the public grid to your Fronius smart meter, three phases going into L1, L2 and L3, and exiting the Fronius smart meter on the bottom side. And then from the smart meter, you can go directly to the backup switch. On the backup switch, you always have L1, L2, L3, and then you go directly over the switch with your household loads and later on also to the Fronius inverter. Please note also in the user manual of the Fronius smart meter, you have two very important things. First of all, to note that you have here a protective cover to make sure that the data communication is separated from the phases on the smart meter. For the installation process itself, of course, we need to have a data communication, and this data communication first starts up with our Modbus RTU line coming here from the Fronius smart meter with 3 pins. So that means that we have here the data plus, data minus and ground connection, as well as a termination resistance 120 ohm to kill the Modbus line on one side. So from there we go from the Fronius smart meter on to the Fronius inverter, and furthermore we need a data communication also on the backup switch to make sure that the backup power mode is active and stays active. First of all, we need to install the so-called WSD contact. This WSD contact now makes sure that the inverter will switch off whenever it reaches the zero position on the backup switch. So that means that the WSD contact is open in zero position, and on the other hand side it must be closed on grid parallel mode as well as in backup mode. So therefore, we are installing our first contact here, the WST contact, with our auxiliary switch. So the backup switch always includes the auxiliary switch, where you can now install the WST contact and close it on position number 1. On position number 2, we also want to close this contact, and therefore we can install very easily here, up here, a cable bridge to make sure that here on L1 contact and down below, the cable bridge is closed, so that WST is closed also in position number 2 in backup power mode. Last but not least, we need to install I6 and I7, our digital inputs on the inverter, and therefore we need to close I6 and I7 with our plus 12 volt signal on the Fronius inverter. So on the data communication side of the Fronius inverter, you will find the plus 12 volt signal as well as input 6 and input 7. And to make installation easier, you can build a cable bridge between I6 and I7 directly on the inverter, and then with one line you go directly on L2 on this contact here to close I6 and I7 with one single line. Please note that whenever you have already installed, for example, a Cat6 cable between Fronius inverter and smart meter, most of the times you can use the open pins that are still left here, the open lines, to make sure that you can install the WST contact as well as I6 and I7. So this has the advantage that you don't need an extra cable coming from the backup switch to the inverter, but you can most of the times use the existing line to install the backup switch. For the 4-pole backup switch, this has now also a neutral conductor connection. Here on the left side, you can now connect the neutral conductor to make sure that this is disconnected as well. To also cable I6 and I7 contact on the right hand side, on the backup position, we also now have an extra auxiliary contact, an extra auxiliary switch to connect I6 and I7. This is due to national standards and norms, because you need to cable the PEN connection double. So that means that L2 and L3 are now covered with the PEN connection. To have easy access to the backup switch, you can remove the cover with the screw on the top side to have access to the contacts below it. This is basically it for the installation part, and next up I want to show you the commissioning part directly on our web interface of the GEN24 Plus. For the configuration of the backup power functionality, we start in the web interface of the Fronius GEN24 Plus with device configuration and functions and IOs. In this section you will find the point backup power, and you can activate this functionality with this little switch here. In the drop-down menu you can now configure your delivered solution. So in this case we are configuring full backup. And after that we can set the nominal backup power voltage, in our case 230 volts. And last but not least, the SOC warning level as well as the reserved capacity can be set. On the right hand side you need to configure your digital IOs. With that, the activation of the backup power functionality is possible. In our case, please make sure to always use the default values. So in this case for backup interlock feedback pin 7, and for the open grid relay feedback pin 6. Please also note, for the manual switchover, no digital input I/O for the activation is needed. So in this case the pin I/O 0 is not needed for our solution, since we are using the manual switchover. The overview is also shown on the right hand side, and when you have configured your digital inputs you can hit the save button to conclude the commissioning system. With this, the installation and commissioning is finished, and you can now use your backup switch within the household. Good luck with that!
We then move on to our backup controller 3PN. This is an automatic version which enables you to back up to 35 amps of devices, single or three-phase, and we're able to automatically switch between the grid, tied and backup mode, and also provide that neutral switching which is required. Please make sure that the Fronius smart meter is on the grid side of the device, as this provides one of the backup fail-safe connections to ensure that the device is operating in the correct mode. If the meter dies, the inverter understands that we may be in a grid failed mode. It will also measure for the voltage from the grid, and if it's able to determine that those essential settings are not available, it will switch into the backup mode. When the grid is re-established, the meter becomes live again. The device is able to then switch back to the grid connection mode and the inverter will reset.
So let's start with the cabling of the backup controller. Please note that we now have a demo installation, and of course in a real installation you need to watch all the national standards norms. So let's start on the top side of the Fronius smart meter. Here we go into the Fronius smart meter coming from the public grid, directly three-phase into the Fronius smart meter, and on the bottom we exit the Fronius smart meter and go directly into the backup controller. Please also note the installation requirements for the Fronius smart meter, and especially, for example, the protective cover that excludes the data communication line from the phases. Please also watch the quick installation guide of the Fronius smart meter. There you also find, for example, the neutral contactor that is needed for the measuring point, and therefore we have a very convenient function here. Since you can use the neutral contactor coming directly from the backup controller, it is noted here with a maximum of 1 amp, and you can directly install the neutral contactor clamp here coming to the Fronius smart meter to make sure that you don't need an extra clamp or extra cabling. Furthermore, we now go three phases directly on the controller. Please also watch here the grid symbol. So that means you have L1, 2 and 3 directly on the controller, where you can now cable your phases to the smart meter and back to the controller. On the right hand side we have now our backup loads, respective the household loads, and you see here you can now directly cable your household loads, your backup loads on the controller as well as the neutral conductor. Please also note there are two conductors for each phase, so L1, L2, L3, and please note you can use them to connect the Fronius inverter directly to the second connection of L1, L2 and L3 if you want to. Furthermore, we need of course a data communication for the backup controller. And this data communication, first up is our Modbus RTU communication between the Fronius smart meter and the Fronius inverter. To have a convenient way of installation, you can now use the Modbus RTU line coming from the Fronius smart meter directly on the backup controller. Please note, this line is only driven through the backup controller and you can exit it again to go to the Fronius inverter directly. So this is just for a convenient installation. If you don't want to do this, you can directly go from the smart meter to the inverter. Furthermore, we need to have, of course, our data communication to enable the backup mode and to stay in it. So therefore, we have the input, digital input 6 and input 7, as well as a plus 12 volt signal and our digital IO 0, as well as the ground contact to close the loop. So therefore, you need to cable these contacts to the backup controller so that it can enable the backup mode and stays in it. And therefore you can directly go, for example, like we did it here, with one Cat6 cable, you can directly go to the inverter, to the data communication of the inverter, and on the backup controller you have written down on the data communication interface directly your contacts that you need to install. Furthermore, we have a little interface on the backup controller, and this will tell you from the front side in which mode the backup controller currently is. So we have one LED for the grid parallel mode and one LED for the backup power mode. So that means that even the end customer can directly see from the front side of the device in which mode the backup controller actually is. And depending on the current situation, the backup controller will now switch automatically between backup and grid parallel mode. The second side of installation is now the commissioning, and the commissioning of the backup power solutions I want to show you directly in our web interface of the GEN24 Plus. You start the configuration process directly under the point device configuration and then under the topic function and IOs. Please note to always log in with your technician account, since you need to be technician to alternate these settings. Down below here you find the point backup power, and we need to activate backup power functionality on the inverter with this switch here, and after that in the drop down menu you can now start the configuration. First of all, we are switching to, in our case, full backup functionality, and then we can set a backup power nominal voltage, in our case for example 230 volts, as well as the SOC warning level, and the reserve capacity can be set in this mask. On the right hand side we have our digital IOs, and please note we always recommend you to use the default settings, so pin 0, pin 7 and pin 6 for the activation of backup interlock, for the backup interlock feedback, as well as for the open grid relay feedback. Since these are the numbers that are also written down on the backup controller, it's always the easiest choice to stay with the default values. So please make sure to configure all these three IOs, and when you are done you can check back the configuration on the right hand side of the page, and when you have that, hit the save button to conclude the commissioning. After this commissioning step, your solution is now ready to use, and you can now use the backup power functionality with your new Fronius backup controller.
But if you need to go onto a larger system where you want to be able to back up an entire 100 amp residential installation, we have a couple of solutions available from third-party suppliers. So Wind and Sun, our distributor, have produced a manual switch which would fit between the Fronius smart meter and all loads on site. This device operates in the same way as the Fronius backup switch, however it has a 100 amp breaking capacity, which means it can be installed right after the Fronius smart meter and include all consumers on site. Just be aware that if you have something like an EV charger or a heat pump, you need to make sure those are switched off during the backup mode to avoid you draining that battery unnecessarily. And if you want to have complete automatic changeover, that is possible as well using our partner Westminster Control's own auto changeover device. And this device has again been devised so that we have a 100 amp breaking supply, and we can back up 50 amps worth of devices with 50 amps segregated into those non-essential loads which will remain switched off during a grid failure. So let's have a look at the backup options that are available. For integrated within the inverter, we have the PV point, which is built into every Gen24 free of charge. That's there already. But if you want to make that an automated device, please purchase the PV point comfort unit, retrofit that into your inverter, and then you have an automatic backup. This is ideal, for example, if you just want to keep your boiler or your refrigerator working during a grid failure. The next option is the manual changeover, and we of course have the backup switch, the Fronius backup switch 3PN, and that's available to operate with single and three-phase loads up to 63 amps. If you need to have that full 100 amp switching load, then please use the Wind and Sun device. Then moving on to the auto changeover options, we have the Fronius backup controller 3PN, which provides those 35 amps of backup circuits, and we also have the Westminster Controls device if you need to be breaking 100 amps for your site. All of these devices are available now, with the exception of the automatic Fronius backup controller 3PN, which is available in Q2 2025. In terms of the backup solutions, we need to consider the software functions that are available with the devices. We can set the battery reserve capacity for the inverters. We can make sure that we have a set amount of energy within the battery which is always reserved for a backup scenario. The key thing to consider, of course, is if we use that reserve feature, that energy will not be available on a day-to-day basis. So only use a reserve capacity which is really critical on your site, maybe 5 or 10% above the minimum charge limit, just to ensure that you can keep the lights on and keep essential loads running. We of course can also set time-dependent charging rules, so we can force the battery to charge from the grid at various times of day. We have our new simple battery control solution within Solar.web, which means that you can easily start a charging session with one press of the button. This is a really good option if you're concerned of a forthcoming storm. You can hold the charge within the battery to make sure that you can cover any potential grid outages. So how do we control the inverter? Well, there are several different ways. Firstly, we can communicate directly with the inverter via the Wi-Fi access point. You can use a laptop or a phone and connect via the Fronius Solar Start app. If you don't want to be going to the inverter, maybe it's in a remote location within the property, you can also communicate via your home network. So if you have a LAN or a Wi-Fi connection to your inverter, make sure that your phone or your laptop are on the same network, and again you can use the Solar Start app and connect to your device. And the third new option that's available is our remote configuration option, which is done from anywhere in the world where you have an internet connection, and again through the Solar Start app or the Solar.web browser version, you're able to then dial into the inverter remotely and securely and change settings such as enforcing the grid battery charging. So first of all, if we're going to connect directly to the Wi-Fi access point, the main reason you would do this is if you don't have an internet connection on site, the only way to communicate with that inverter is directly with the device. So you need to go to the inverter, enable the Wi-Fi access point, and then you take the Solar Start app, connect to the inverter's Wi-Fi access point, and you can use the Solar Start app to program the device as needed. The easiest option if you're at home is to connect via your LAN or router and use again the Solar Start app. This time when you connect to your local area network, the Solar Start app will be looking and searching for Fronius devices on your local network. If you have multiple Fronius devices, you'll see the serial numbers listed. Make sure you choose the correct device and you'll be automatically taken to the browser interface for the inverter. Here you can make the changes to the settings as required. We have put together separate how-to videos showing you how to connect to the devices. The new feature, remote connection, is a really important step forward. We can now use our smartphone anywhere in the world to enforce a charging session. As long as you have an internet connection to your mobile phone and you have an internet connection to your Fronius GEN24 inverter, the devices are able to communicate over a secured network and you are able to make changes to your settings remotely. The simplest solution is using the new battery control feature from within the Solar.web app. This will be released during March, so keep an eye out for software updates available for your Fronius Solar.web app. And what you'll be able to do is at the bottom of the screen, start a battery control charging session. This will slowly charge the battery at 1.5 kilowatts until it is fully charged. The battery will then hold its charge for 24 hours. This energy is only then discharged if there is a grid failure, or alternatively if you decide to unlock the battery and allow it to charge back to the property. If you want to make more complex changes to your system, we'd recommend using the Fronius Solar.web remote access. This can be done from anywhere in the world, provided you're connected to the Fronius Solar.web browser version. Go to Settings, then go to Components, and you shall see the inverters listed. On the right hand side there is a small button under Actions. Click on this and you can then connect to the device settings. After a few seconds, the device will attempt to open a connection to the inverter and you will then have access to your device. From here you can make changes to the battery time of use charging, maybe add a reserve capacity to the battery or change any other settings within the device. Finally, another really important product that's coming from Fronius in the coming months is the Fronius Reserva battery. The Reserva is Fronius' own battery solution. It is designed specifically to work with the GEN24 and Plus inverters. It is a modular solution, and you can build it up between 2 and 5 battery modules, meaning that we can have stacks of 6.3 up to 15.8. We can then parallel stack up to 4 of these towers, meaning that we can have a maximum system capacity of 63 kilowatt hours. Of course, we're using lithium iron phosphate technology, which is the most stable, safe, secure, reliable battery technology on the market. The great advantage with this solution is that all of the technical support will be provided by Fronius from here in Milton Keynes. It means we will be holding the spare parts, and we will also be fully responsible for making sure that the technical support is provided for both the inverter and that new battery. The start of sales is planned for June 2025, with products going to distribution in May this year. Also, it's very important to mention that Fronius have a strong focus on data security. So any data communications between Fronius GEN24 inverters, our Reserva batteries, and also with our servers are fully controlled within the European Union. This means that we have that local data security and that robust data connection. If you want to find out more about the Reserva, that information will be provided within our webinar from Fronius International next week. So please stay tuned for that. We'll put the invitation for that into the chat notes for this webinar. Also, please be aware that if you are familiar with the BYD HVS and HVM batteries, we are still fully supporting those products. They're still available, still supported by us, and they still provide a very good, very competitive battery storage solution. So I hope the products you've seen today will be very useful to you on future projects. Additionally, of course, these devices can be retrofitted to existing installations. So if you have any technical queries or you need support with projects, please get in contact with us through Fronius Tech Support. We'd be delighted to discuss any projects with you. So thank you very much for joining us today, and we look forward to supporting you with future projects.